Welcome, Nathan. I'm really excited to have a conversation with you today. Would love to have all the folks who are listening to our Hanger podcast learn more about Dora metrics right from the person who evangelizes it. So, Nathan, why don't you do a quick introduction and we'll get started?
Awesome. Thanks so much, Ankit. I'm really excited to be here on the Hanger with you today. Hi, everyone. My name is Nathen Harvey. I lead up Dora at Google Cloud. Dora is a research program that's been running for well over a decade now, and it's all about how do teams get better at delivering and operating software.
That's amazing. So, why don't you walk us through a little bit of evolution of Dora? Like, where did it start, where it is today, and kind of like all the things that has happened since?
Yeah, for sure. So Dora, like I said, it's been going for over a decade. The research actually was started by Puppet Labs back in like 2013. So Puppet Labs, or they were called Puppet Labs at the time, I believe. Then they were eventually called Puppet. But in any case, they saw this DevOps movement sort of growing in the community and in the industry and said, I wonder what we could learn from this. And so they launched the first State of DevOps survey. I was a participant in that survey. At the time, I was managing a bunch of web infrastructure, and so I was really excited and part of the DevOps community, excited to participate in that and see what we can learn about ourselves. So over the years, that research has kind of continued. And I think it was around 2014 or 2015 where Dr. Nicole Forsgren joined up with Puppet to help bring a little bit more science and an analytical approach to the research. Dr. Forsgren was working in university and was teaching statistics classes and was doing a bunch of research into the state of the art of system administration and IT practices and so forth. So she left academia and came into industry and really helped drive that research with Puppet. A few years later, she and Jez Humble and Gene Kim all co-founded a company called Dora. Later on, Dora was acquired by Google Cloud. That was about 2018, towards the end of 2018. And once it was acquired by Google Cloud has maintained our sort of influence and driving that particular research study. There are some really key things about that research study. The first and foremost, I think, is that it is program and platform agnostic. It really seeks to understand using good analytical, statistical data analysis practices to understand how teams, like I said, are getting better at delivering and operating software. What are all of the impacts? Dora looks a lot at the culture and the people. In fact, we might be people first, and then process, and then technical capabilities, things along those lines. So at Google Cloud, we've continued to drive this research forward. As I said, we just closed the 2024 annual survey. So we're right now beginning that deep data analysis to figure out what are all of the impacts of the things that we looked at in 2024.
That's amazing. So let's dive a little bit more into what goes in behind the scenes. More specifically, surveys is a big part of the whole research.
Yes.
So share a bit about how are surveys designed? Like, what are some of the core theses behind surveys? And maybe we can also talk about how has surveys evolved over these years?
Oh, yeah, for sure. So you're right. We do use surveys as the primary data collection vehicle within our Dora research. We use surveys for a number of reasons. First, we want to make sure that we can go broadly around the world, talking to organizations of every shape and size. Unfortunately, all of those organizations won't just give us ready access to their data, so we can just suck all of their data into research. So surveys is a good way for us to gather a bunch of data. Of course, if we were to suck in all of the data from all of those teams, it'd be in so many different formats and everything. You can imagine the integration effort that would be involved. So surveys is a really a good way for us to gather that data. Now, surveys are not easy. Surveys there's like a whole art and science to writing surveys. We want to ask good questions. I'll give you a couple of examples of bad questions. Do you like the color orange, do you like the colors orange and purple? And you could maybe you like them both. Yes is an easy answer. Maybe you only like one of them. What do you answer there, right? We call these kind of double-barreled questions, if you will. We want to make sure that we're only asking one thing in every question that we ask. But then there's also the question of where should we investigate? So one of the things that Dora has done for a long time is say, first, we're going to focus on software delivery and operations. So what does it take to go from committed code to that code running in production? And once it's running in production, how's that going? And we want to look at things like the impact of that software delivery and operations on things like organizational performance and well-being for the people that are in those organizations. And then software delivery performance, like that's a big area of study. How do you measure that? And so Dora came up with these 4 key metrics, which maybe we'll talk about in a little bit, to help us understand how you measure software delivery performance. And then we also want to understand, well, what are the things that drive software delivery performance? And this is where we really get into the survey design, where the researchers and the team get together and we come up with some hypotheses around what do we think might drive software delivery performance. I'll give you a simple example. Using version control. If you use version control, you're going to have better, technical practices. That's going to drive better software delivery performance. Great. But we can't just ask, are you using version control, yes or no? We have to get a little bit more detailed about that. So that version control kind of becomes a construct. And then we ask 3 or 4, or sometimes 7 or 8 questions that help us identify how is a team adapting to that particular construct or capability or idea that we have. Once we gather that data, we can then say, oh, this capability or this construct is predictive of better software delivery performance, or maybe it's predictive of worse software delivery performance. And then we take all of these constructs and we're able to draw a map to sort of understand how they all influence one another. Another good example, if you're not using version control, it's nearly impossible to do continuous integration because continuous integration kind of depends on having version control in place. At the same time, we can look at the impacts of how they all impact one another. So a great example in our 2021 research, or maybe it was 2022 research, we looked at security practices. And one of the things that we found was the biggest predictor of better security practices was an organization's culture. Not any of the tools or technology that they use, but how do people collaborate and communicate and share information? This was the biggest predictor of better security performance. So we kind of take these constructs and build out this map that sort of shows how they're all interacting and interplaying with one another so we can make the best decisions. The whole goal, though, is to help teams understand first how they're doing today. That's where those delivery metrics come in. But then, probably more importantly, what should they focus on improving next? So using our research and the methods, they can probably find a constraint or 2 within their system. We really kind of want to teach the theory of constraints. If you want to make an improvement to a system, start with the thing that's holding you back. Make that a little bit better. And really, at the end of the day, what Dora emphasizes and tries to promote is a mindset and a practice of continuous improvement. And this is why at Dora right now, one of our taglines is get better at getting better. We just want to help you do that.
Amazing. So this is very fascinating. I didn't realize it was such a deep dive in terms of understanding more specifically the challenges, which is also fairly complex problem, right? Like software
Yes.
development itself is a multi-dimensional work, right? It's very hard to kind of measure productivity and even identify bottlenecks. So given that you do surveys only once a year, right? How do you, and the way you described it almost felt like you kind of do almost back and forth interaction, which is kind of many times a platform or a dev productivity team internally in an organization would do. How do you kind of design that within the service? Is it sort of you ask a question and based on the answers there's kind of more deeper dive? Because once you get to a point, it's okay, we need more info, you now have to wait another year to get that information, right? So how are kind of those things covered in the surveys?
Yeah, the truth is we'd love to be doing surveys once a week or 2 times a month. But then the balance of that, of course, is that it's very difficult to get broad participation in a survey every 2 weeks, right? So how do we deal with that? Well, of course, we do an annual survey, but we also stay very much in tune and in touch with the community. So in fact, a few years ago, we launched Dora.community, which is a place where practitioners and leaders and researchers all come together to discuss these topics and figure out how do we take this research, which is, it's academically rigorous research, but maybe the work that I do isn't so much academically rigorous. How do I take that academically rigorous research and put it in context of the work that I'm doing so that I can actually start driving improvements? And so through the Dora community and through interactions that our team has with teams around the world throughout the year, we're kind of seeing how is this playing out. And that helps us identify trends and figure out, okay, well, next year, Where do we want to focus? So, it's no surprise, or it will come as no surprise to you, that in 2024, AI is one of those things that we're focusing on. Like, what is the impact? How do we start measuring this? How is it impacting developer productivity? How's it impacting software delivery performance? How's it impacting the well-being of folks on the teams?
I know kind of like also AI has finished one full cycle. So there was also some aspects of AI in 2023, and we'll come to that. But before kind of like, we dive into AI, why don't we do a quick review for people who don't know what are like the 4 key metrics? And I would also like to understand, in 2021, there was a mention of reliability as a 5th metric.
Mm-hmm.
And what happened to that? Kind of like, maybe share a bit more on that too.
Yeah.
Because that's like the lesser spoken metric as well.
Yeah.
Or like parameter.
For sure. That's a great question. Thanks. So we'll start with the 4 key metrics for software delivery performance. And when you think about software delivery performance, we look at 2 different sort of categories, if you will: throughput and reliability. So if we're thinking about changing, this is what we're thinking about. Software delivery performance is about changing a running system. So the 2 throughput metrics that we look at are lead time for changes and deployment frequency. So the lead time for changes, it starts when that code is committed to version control, and it ends when that code lands in production. So it's ready for a user to interact with. That's your lead time for changes. And then how frequently are you pushing those changes to production? That's your deployment frequency. So of course we want to accelerate. There's pressure everywhere to accelerate. We have to go faster, Ankit, as you know. But we don't want to just go faster and break everything. So this is where the stability metrics come in. And on the stability side, we want to make sure that those changes that we're pushing land in a stable way, that don't cause problems for our users or for our systems. So the first one we have is the change fail rate. I honestly, I like to call this the expletive rate, because it's how frequently when you make a change to production, do you or someone around you shout out an expletive? Ooh, expletive. We shouldn't have pushed that. We've got to pull that change back or push forward a hot fix. We would consider that a change failure. We want to minimize those, of course. But the truth is, those failures are going to happen. Like, no system is 100% perfect. So our final stability metric is the failed deployment recovery time. So when there is one of those expletive moments, how long does it take you to restore service for that running application? Now, interestingly, what we found when we look at throughput and stability, historically, there was an assumption, a belief, that these 2 were trade-offs of one another. Either you could be fast or you could be stable. But what our data shows consistently for over a decade is that teams that perform well across all 4 of those metrics, that tells us that these metrics are moving together, sort of in lockstep. So we see teams performing well hit all 4 of those metrics really well. Teams that have, we'll call it a lot of opportunity for improvement, they tend to score much lower across all 4 of those metrics. So I think that's a really interesting pattern. Now, you get to that 5th metric, reliability. And this is really interesting. So in 2019, the Dora research introduced availability. That was really a measure of operational performance. And availability is maybe a little bit too tightly defined, although the intent even at the beginning was it's a measure of how well your systems are able to keep their promises to your users, which is really, we would say in today's parlance, maybe more about the reliability of the system than the availability of this system. And availability, maybe, you kind of think of uptime as an availability component. Right. So we want to expand that measure a little bit to include reliability of the system, which might include things like latency or correctness, things along those lines. But all told, we call this operational performance. Now, I'll be honest, sometimes we call that the 5th metric, reliability. But the truth is, we have 4 metrics for software delivery performance, and then we have another set of metrics around operational performance. And, writing software and getting it delivered is different than running software and keeping those systems running. They absolutely play in the same space, and they inform and reinforce one another. If you have trouble with operations and you can't ship software, you're going to continue to have trouble with operations, right? So they're linked, but I think that we made a little bit of a mistake. Maybe we've learned a little bit over time that it isn't really a 5th metric. The other thing that's true is those operational measures are a little bit, even more so, context specific to the application than those metrics of software delivery performance are.
Can you give an example, like why they're more context specific? Because it does sound like for operational reliability or performance, there aren't really like as concrete metrics that you can like just go plug and play and get
Yeah,
better
yeah,
understanding of
I'll
this.
definitely give you a great example here. So first, let's talk about how those four software delivery metrics are acceptable and like broadly applicable.
Mhm.
You can think about different types of applications. You've got an application on your mobile phone. Well, how frequently are you releasing it? How stable are those releases? You maybe have a mainframe sitting around. You probably don't have a mainframe in this hangar, do you? This hangar's well too new for that. But some teams still use mainframes, and you can measure the delivery performance of the applications on that mainframe using those same four metrics. When we flip over to the operations side, now we get even more context specific because think about this. Let's say you're working in a bank. Oh, well, a bank must have extremely high reliability requirements, right? Well, it depends on the application. In that bank, you have a retail banking application. Yeah, we want some high reliability there. We might be doing industrial like bank transfers. We want high reliability there. You know what else they have in that bank is a cafe for their employees, and there's a menu application for that cafe. Does that need the same reliability that you need for the retail banking application? I would argue it doesn't. It does around lunchtime for sure, but outside of lunch, it can stand for some downtime. It can stand for way less reliability. What's the worst that happens if in the internal employee cafe, if I go online and the menu is down? Well, I'm probably just going to walk down to the cafe. I'm going to keep using the cafe. That's okay. That's very different than going to my bank and finding that their website is down.
Interesting. I would so curious, like why would that not apply to change failure rate or like rather recovery time, right? Because mean time to recovery is sort of like a little bit more operational
Oh,
reliability specific.
yes. Yeah, that's a great question. And in fact, what you've done is kind of uncover one of the ways that those four metrics has changed. So before 2023, we talked about that last metric as the time to restore service.
Hmm.
In 2023, we changed the phrasing of the question and we altered the topic of the question a little bit. It's now called the failed deployment recovery time. When you think about a time to restore service, really that question was asking about time to restore service from any type of incident or outage that happens. So again, let's assume for a minute that we're working, our applications are deployed in a data center and
Hmm.
a backhoe comes along and cuts power to our data center. How long does it take us to restore service to the applications that we're running in the data center? I don't know. It's a long time probably, but it's a very different answer and a very different response than if you pushed out a bad configuration change. How long does it take to recover from that? Comparing those two types of outages is kind of comparing apples to oranges, right? It's not an equal comparison. And in fact, in the sort of reliability engineering or resilience engineering community, there's a there's a strong movement against or away from MTTR as a valid measure because you just can't learn as much as you might like to. So in 2023, we said, that recovery time is really about software delivery performance, which is why we sort of zoned it in or zeroed it in on this one particular type of failures, a failed deployment. So when you push something and something goes wrong, those are the types of failures that we want to look at. Unfortunately, when you look at failures that happen in systems, oftentimes, probably the majority of the time, the reason that they fail is because we've introduced change.
Interesting. So let's switch gears a little bit. Would love to dive into AI, which
Yeah.
is like the talk of the town for like over a year now. So share a bit about like also from like 2023 results which are already out. Like what were some of the key findings and what are some of like the key, uh, I would say maybe from the survey perspective, like kind of like the key areas that we are diving into.
Yeah, absolutely. So in 2023, we did absolutely look into AI, but we didn't go very deep. We kind of went to the surface level. We essentially had about two questions around this. What are you using and how important is it to the tasks that you're trying to complete? And what we found was that more than half of our survey respondents were using it for something. It was at least mildly important for some of the tasks that they wanted to complete. But as we looked at the impacts that drove, on the good hand, one of the things that we saw was that there was a moderate improvement to the well-being of people that were using those AI tools. So What is well-being? Well-being is a measure of how much burnout do you have, job satisfaction, team performance, things like this. So it's good to see that, right? If I'm an engineer and I get to play with the new toys, AI being one of them, I'm more engaged with the job that I'm doing. I have higher job satisfaction, less burnout. This is exciting new technology. That's why I got into engineering, so I could play with exciting new technology. So that's really good to see. Unfortunately, in 2023, what we didn't see was AI impacting software delivery performance, operational performance, organizational performance. Like we didn't see the value flowing all the way through the system. We hypothesize that with a giant yet. We don't see that yet. We think that in 2023, everything was still so new. So, of course, this year we're investigating it and going a little bit deeper, trying to understand, again, where are you using it? How are you using it? How much trust do you have in it? How much permission do you have to use AI? You know, many organizations are still kind of defining what their acceptable use policies might be for different AI components within an organization. So how is that impacting the use and impacts of AI? I suspect that we're going to find lots of interesting things. We don't know yet where it's going to go. But I also think we recently published on Dora.dev a guide called How to Enable Your Software Delivery Teams to Innovate with Generative AI. And
Okay.
in that guide, we provide some high-level guidance that really talks about how do you think about injecting new technology, Gen AI in this case, into your software delivery process. And maybe not surprising, but we kind of want to take a measured approach. And by measured approach, like start with a baseline. How are you doing today? Make sure that you understand how your software delivery performance is, and make sure that you have those before and after measures so that you can really see the impact of injecting more generative AI. In fact, the thing that I do with teams all the time is we'll look at their software delivery process, try to map it out and understand where are the bottlenecks? Where are the bottlenecks within your software delivery process? And let's see, could we inject some AI into one of those bottlenecks? What would that look like? Let's make sure we have measures of before and after and see how we alleviate that pain. And in fact, one of the things that we did find in 2023, unrelated to AI, but I think I'll make it related in just a second, is we saw that teams with faster code review times have 50% better software delivery performance. And
Interesting.
I just read an article on the news stack, I think, Ankit. Didn't you write that article? Yeah. That was all about code review times. Yeah. And I think that this is, and one of the things I loved about your article, just for a second, is that you really captured the complexity of code review. Code review, when we talk about Dora research, we talk about tech, process, and people. Code review is sort of the summary, like a focal point for all three of those things. It's about the technology, the process, and the people. How do they all come together to enable code reviews? You gave some really great advice there, like don't think about the entirety of the code review time, but think about the various pieces. You need to break that down into smaller chunks. Like how long does it take for me to get a first response? How many back and forths do we have as we're going through that review cycle? So I think that was first really great guidance. But also I think that this is because we see such impacts on software delivery performance. And this, as you know, is a significant bottleneck in a lot of different teams. So it makes it kind of an obvious place to start experimenting with how can AI help with that. For example, one of the things that you mentioned was maybe you have very few experts in this particular area of the code. Can AI help with that? Can AI help make sure that we're getting the code into the hands of those experts? Maybe we have other experts that we haven't been able to identify, but the AI could help us say, oh, well, Ankit has made a ton of changes in this area of the code base. He's not listed as an expert, but he might have the expertise in order to do this code review. Something like that. I don't know. I'm kind of, theorizing here on some of the different ways that AI could play in.
Awesome. And thanks for the plug on the article. Yes, I think a lot of these learnings come from like my observations also from past at Google. But like I think code review is also an interesting aspect. I think especially from AI perspective, I would love to hear how you think about it because now we have things like coding assistants, co-pilots, those kind of things, and we have like code reviews which are done by AI, right? There has to be some balance, right? Like I feel either it's like okay, your code review well, your code is written by humans and then reviewed by AI, or it's like code is written by AI and then like reviewed by humans, right? In some way, there has to be a human in the loop. Where do you see AI is being more successful, or kind of like where do you see kind of like how do companies build that balance, especially when it comes to code reviews?
Yeah, for sure. I think so. One thing another article I'll plug is Google published some research about some of the things that we've done internally lately, specifically around the code review process. And one of the things that we're doing when a commenter goes and starts making a comment on your code, the AI will suggest a change to that code. And the commenter in that moment can accept that change and say, yes, recommend this to the original author or not. And then the original author can accept or not that change. So injecting AI, something like that, I think is really interesting. Another thing that you mentioned in your article is that human nature of, look, if there's 1,000-line code change, it's going to take me longer to review it. I want to push back on that a little bit. If there's 1,000-line code change, I'm going to stamp it. Yeah, it looks shorter code changes I'm actually going to look at. But
Right.
here's an interesting thing. Let's say you've written 1,000-line code change. Can you ask the AI to help you break that up into smaller chunks that are easier
Interesting.
to review? And maybe the AI can help guide you to, hey, if we just do these 200 lines, this will be reviewable and deployable without causing other impacts or negative consequences. So help you maybe break up some of those things. So certainly I fully agree with you. There still should be a human in the loop. And that human should probably, on both sides of that loop, should be using AI to help improve their practices. Oh, and that's a special word, their practices, right? I think AI is still so new. We are all, as an industry, developing new practices with it. And I think it requires that building up that practice, building up the muscle of how do you interact with AI in the most effective ways. And as you learn them, please share them with the community so that we can all take advantage of that.
Amazing. And one other part I would want to at least touch on, as kind of like many companies are exploring AI, is security and compliance, right? A lot of these things, especially with like generative AI writing code, like again, reviewing code as well, right? Like you can't have a generative AI model writing code as well as a generative AI model reviewing code because then there's no human in the loop. But I'm curious, like, what is your recommendations or thoughts around like security and compliance? Is this kind of like itself evolving? Kind of like where do things lie? How should like some of the larger enterprises who are more kind of like working in the I would say conservative space or like restrictive space, how should they think
Mhm.
about adoption of AI?
Yeah, I think that I think it's a new space. We're all still learning a whole lot. I don't have a whole lot of deep experience with AI and security, but some of the guidance that I would give just on my own lived experience and the Dora research is, look, we're always pushing for more automation. So let's find the ways that the AI can help us find and remediate those potential security holes. We can validate that we aren't introducing new holes. Again, I think it is still really important to have that security professional in the loop. But if we can go from policies that live in PDFs to executable code that can validate those policies, that to me is the right thing to do, and the only way forward that we can continue to accelerate this. So baking those security controls into your pipeline, making sure that a security test is run as frequently as your unit tests, and importantly, giving developers access to those tools, access to both write those tests and to get immediate validation. We want to drive this process of fast feedback for our developers. That's the name of the game, right? Every line of code that we write is an experiment. Help me validate or invalidate that experiment as quickly as possible.
Very cool. And so moving outside of code reviews, where have you seen kind of like, AI driving some, or like kind of like when I say code review, both writing as well as reviewing, where have
Mhm.
you seen kind of like in the software delivery pipeline where AI can possibly make a big shift?
Yeah, for sure. I think first and foremost, obviously, we're seeing a lot of people writing more code together with code assistants, right? And that includes writing additional tests. So even if you come to a code base, maybe you've moved to a code base that's brand new. How do you understand that code base? AI can be your friend there in describing what's happening there. Maybe you come to a code base without any tests. Oh, let's leverage the AI to help us write some tests for that, please. It's important work. And again, we will be able to verify that those tests look good, but let's get those tests up and running. I think that's really, really important. And then there's also, another big constraint that we have oftentimes in software delivery processes is a change approval process. And this is, it falls after the code review oftentimes, but maybe your code goes off to a change approval board and there's a lot of auditing requirements and sort of evidentiary requirements that go along with this. Let's use AI to help us build up that automation and streamline that process. One of the things that we've found over our research at Dora with heavyweight change approval processes, a heavyweight change approval process, it's just bad all around. It causes a lot of negative effects. No surprise it slows you down. That's kind of obvious. But we've also seen in our data that with a heavyweight change approval process, it slows you down and it also decreases those stability metrics. So your change fail rate goes up. That's completely not the intent of those boards. They're there to minimize risk, but that's exactly what happens. Not only that, but when there is that heavyweight change approval process, it's oftentimes opaque to the developer. They don't understand what happens. So as a developer, if I don't know what it takes for my code to go from committed to approved, when I'm in that state, it's harder for me to disconnect from work, and we see burnout going up and job satisfaction going down. So it's impacting the human's well-being as well. So I think that the change approval processes that you have, this is another really powerful place to look at injecting not only AI, but AI and a bunch of automation and other things.
It's amazing. We're definitely living in a very interesting time. I do
Yes.
believe like there's going to be a lot of shifts, and I'm looking forward to also like 2024 survey results, see kind of like where things are. Before we drop off, I do want to at least like touch up on how Google internally uses and thinks about Dora itself, because I left Google 10 years ago, and Dora didn't exist back then.
Right.
So would love to kind of like hear, what has been the internal discussions around Dora's kind of like, adoption, like, and understanding within the engineering organization of Google.
Yeah, for sure. As you know, even 10 years ago, Google made significant investments in understanding developer productivity. And we have this whole engineering productivity research team. And of course, we have product like hundreds, thousands maybe of engineers that are dedicated to improving developer productivity for all developers within Google. Their research methods are quite different to Dora's research methods. Dora goes out and tries to get information about as many companies and organizations and industries as possible. So we're really wide, survey-based, trying to get a good understanding of state of the art around the world. That engineering productivity research has access to all of the data that is inside of Google, and we understand all of the interactions. So they're kind of the two have very different objectives and goals. That said, there's certainly a lot of sort of cross-pollination that's happening. From the Dora perspective, we're looking at those EPR, the ways that EPR is looking at how do we measure Google developer productivity, and we're taking some lessons from that and trying to replicate their findings and their data out in the external world. And at the same time, we're providing them some of the things that we look at. We also see some teams within Google. Oftentimes, these are teams that are maybe have leaders that joined Google within the last few years that are coming in and saying, hey, these engineering productivity research insights are really good. I also want the Dora metrics. And so they're starting to build up, how do I pull this out of Google systems and build dashboards around Dora metrics? So there's a lot of collaboration that's happening, I would say, and a lot of reasons and good things why they're still kind of separate, right? We also never want to turn Dora into a research that comes out and reports how Google does things. We want to make sure that our research is broadly applicable. So this is kind of why there's some differences there across those two as well.
Interesting. And a lot of organizations also have started doing surveys internally themselves for developers.
Yes.
Like, do you have recommendations on how should that interplay with Dora?
Yeah, absolutely. I think there's a couple of things there. So first, one of the things that we do with Dora is we publish the questions that we ask in every survey. So over at Dora.dev, if you go to the research area of Dora.dev, you'll find the questions asked in each year. So if you're running your own internal surveys, please liberate some of those questions. Take some inspiration from them, at least understand how we ask these questions, and that might help you as you build out your own surveys internally. But then, of course, take the lessons that I just shared about EPR. You've also got access to the data in the systems within your organizations. So you should never just take one thing off the shelf, I would say, but customize it for your organization, put it into your organization's context. And when it comes to pulling in that data, of course, there are also lots of vendors out in the space today, in that SEI space, or software engineering insights, that can really help with a lot of integration and creating dashboards and providing, well, just what they said, insights into how your team is doing. And of course, not only are there commercial products, but there are also source available products that are out there. In fact, on the resources section of Dora.dev, we list a couple of those source available products that will help you visualize your Dora metrics.
And is Dora.dev like the central place where people can go to find more information?
Dora.dev is that place, absolutely. So there's Dora.dev, and from Dora.dev, you'll find a link over to the Dora community, Dora.community. That's where a lot of the interactions happen across organizations, and where we're sharing a lot of learning as well.
Nice. Awesome. Well, Nathen, thank you so much. This was a pleasure chatting with you and learning so much about Dora and Dora metrics. I look forward to chatting further as we move along and learn more about like how AI is evolving everything in the software development.
Awesome. Thanks so much for having me here in the hangar, Ankit.
Thank you so much, Nathen. Have a good day.
All right. Bye-bye.